What if an interstellar object passed through our solar system and we missed the most important moment to understand it? Right after 3I Atlas moved close to Mars, a long-running NASA spacecraft went silent, and the data went with it. Since then, strange alignments, unlikely timing, and unresolved signals have fueled a quiet scientific debate. Are these coincidences or signs that we are overlooking something fundamental? If you find this analysis valuable, please like the video and subscribe. Now, let's begin. MAVEN had been circling Mars for more than a decade, doing its job in a steady, almost routine way. Then, right after 3I Atlas swept past Mars at a distance close enough to matter for science, the spacecraft went quiet. The official story starts with something simple. MAVEN passed behind Mars, and for a short time it could not see Earth, so it could not talk to us. That blackout is normal, expected, and it has happened many times before without drama. What made this event feel different was what came next. When MAVEN should have come back into view and reconnected, there was nothing, no signal, no handshake, no faint carrier tone, just silence that stretched far beyond the usual window. If you think of it like a call dropping in a tunnel, this was the moment the car exited the tunnel and the phone still never rang again. For a spacecraft with a long track record of surviving these same geometry-driven blackouts, that timing is hard to ignore. The uncomfortable part is not the blackout itself, but the coincidence of the blackout lining up with the most interesting visitor Mars had in years. 3I Atlas was not just passing by in the far distance. It came within tens of millions of kilometers, close enough that instruments near Mars could, in principle, measure changes in particles, fields, and gas around it. Then MAVEN went silent soon after returning from behind the planet, right when people expected the first real look at what the spacecraft had collected. Even if the failure is ordinary, the timing invites a question that splits audiences fast. Was this just bad luck? Or was it connected to what MAVEN had just observed? NASA's early explanation stayed grounded. An expected communications gap occurred, and the team was working a problem when the signal did not return. That is a normal way to speak about spacecraft trouble, because most spacecraft trouble really is technical software glitches, power issues, aging parts, or a fault triggered by radiation. Still, for anyone following 3I Atlas, the quiet created a vacuum, and vacuums get filled. Some people filled it with the safest answer. The space is hard and machines fail. Others filled it with a more charged possibility, that MAVEN's failure happened at the one moment it could have delivered the most sensitive data about a strange interstellar object. And that is why it feels like more than a random outage. This is where the debate begins to heat up, because both reactions sound reasonable at first. Spacecraft do fail, and Mars orbiting hardware does face harsh conditions, including radiation and temperature swings. At the same time, MAVEN had been stable for years, and the public was told it had collected valuable readings during the close passage, including data linked to the encounter distance of roughly 30 million kilometers. When you put those facts side by side, a simple question becomes hard to answer cleanly. If this was a routine malfunction, why did it happen right after the most important dataset MAVEN might ever capture outside of its normal Mars mission? A second question follows right behind it, and it is even sharper. If MAVEN did record close-range information about 3I Atlas images, particle readings, or signs of a plume, where is that data now? If the spacecraft cannot talk, then the data may be trapped on board, waiting for a link that never comes. That is the kind of detail that turns a technical failure into a public mystery, because it creates a gap between what might exist and what can be shared. You do not need a conspiracy theory for that gap to feel unsettling. You only need the sense that something important may have been seen and then locked away by silence. By itself, MAVEN going quiet does not prove anything about 3I Atlas. A coincidence is not a cause, and the universe produces strange timing all the time. But this particular coincidence lands in a place where people already disagree. Because 3I Atlas was already raising questions before MAVEN failed, the spacecraft silence did not start the suspicion. It poured fuel onto it, because it happened at the exact moment the story needed clarity most. Before MAVEN went quiet, it was in a position few spacecraft ever reach at the right time. For more than 10 years, it had been built and tuned to sense the invisible environment around Mars. Not just pictures, but charged particles, thin gases, and changes in electric and magnetic fields. Those are exactly the kinds of signals that do not show up clearly in telescope images from Earth. If something unusual passed nearby, MAVEN was designed to notice it in quiet, indirect ways. During the close passage of 3I Atlas, MAVEN's instruments were likely sampling the space between Mars and the object, measuring how particles flowed and how the local environment reacted. This is not the kind of data that produces dramatic photos. Instead, it produces patterns, small shifts, and traces that only make sense when lined up over time. To a scientist, those subtle changes can be more valuable than a clear image, because they reveal how an object interacts with space itself. That is why the idea of MAVEN collecting data during this window matters so much. NASA confirmed that MAVEN gathered scientifically valuable measurements during the encounter, including readings taken when 3I Atlas was within roughly 30 million kilometers. That statement alone raised expectations, because it suggested the spacecraft was doing exactly what it was meant to do at the most interesting moment. Then, almost immediately after, the flow of information stopped. No follow-up plots, no detailed breakdowns, and no release of raw measurements. Only the explanation that the spacecraft was no longer reachable. For many listeners, this is where frustration starts to replace curiosity. If the data exists but cannot be sent back, there is no way for outside researchers to examine it, question it, or confirm what it shows. That absence creates a strange imbalance, where officials can say data was collected, but no one else can see it, even if nothing extraordinary is hidden in those readings. The situation feels incomplete, like reading a report with the most important pages missing. Some researchers pointed out that MAVEN was in a rare position to detect things Earth-based observatories could not, especially if 3I Atlas released gas, plasma, or fine particles as it passed by. Those signals would not travel far, and they would fade quickly. If MAVEN detected something out of the ordinary during that short window, losing contact afterward means losing context as well. The data becomes frozen in time, with no chance to check it against later measurements or repeat the observation. At this point, the debate splits again. One side argues that space missions do not owe dramatic answers, and that a lost spacecraft is simply a loss, Not a message. The other side sees a pattern forming, where the most direct witness to 3I Atlas at close range is suddenly unable to speak. That reaction is not driven by evidence of wrongdoing, but by the simple fact that silence arrived exactly when clarity was needed most. What makes this especially difficult to dismiss is that MAVEN's role was never about spectacle. It was about quiet, reliable sensing, the kind of work that rarely makes headlines. When such a tool goes offline right after a rare encounter, it naturally leads people to ask what it might have recorded in those final moments. Until that question is answered, MAVEN's silence remains less like an ending and more like a pause, holding attention on what may still be sitting, unread, inside the spacecraft, even without the silence from MAVEN. 3I Atlas was already drawing attention for reasons that had nothing to do with spacecraft failures. From the earliest orbital calculations, astronomers noticed that this object did not behave like a typical interstellar visitor wandering in from deep space. Its trajectory lay remarkably close to the ecliptic plane, the flat disk that defines the paths of Earth, Mars, and nearly every major planet in the solar system. For an object arriving from outside the system, this alone was enough to trigger careful discussion to see why this matters. It helps to picture the solar system from the outside. The planets are arranged like a thin, spinning record, while interstellar space surrounds it in all directions. An object entering from far away has almost unlimited angles of approach. Most would slice through the system at a steep tilt, passing far above or far below the planetary plane. For one to arrive almost perfectly aligned with that plane requires a very specific geometry, one that does not naturally stand out as the most likely outcome. Researchers estimated that the chance of such an alignment happening randomly is about 2%. That number is not small enough to ignore, but not small enough to claim certainty either. In science, this is the uncomfortable middle ground, where something is rare enough to be interesting, but common enough to resist strong conclusions. Still, when dealing with only a handful of known interstellar objects, even a 2% event carries more weight than it would in a much larger sample. This is where opinions begin to split. One group argues that rare things must happen sometimes, and that we may simply be noticing this case because it stands out. They point out that the galaxy is vast, and countless objects pass between stars unseen. From that perspective, 3I Atlas could be nothing more than the first oddball we happen to catch. Another group responds that this explanation relies too heavily on unseen numbers. When observations are limited, each data point matters more, not less. What intensifies the debate is the meaning of the ecliptic plane itself. This is not an empty region of space. It is where planets orbit, where gravitational interactions are strongest, and where observational coverage is richest. An object traveling along this plane has a higher chance of close encounters with planets, and a higher chance of being noticed by instruments spread across the inner solar system. Whether intentional or not, such a path maximizes interaction. In simple terms, nature has no known preference for sending interstellar objects neatly along the solar system's main disk. There is no cosmic funnel guiding them into alignment with planetary orbits. Most should arrive skewed, tilted, or even nearly perpendicular. 3I Atlas did not. Its path appeared smooth and orderly, as if it had been threaded through a crowded space with care. Even though no physical mechanism demands such behavior, this alone does not point to design, but it does raise the cost of dismissing the object as ordinary. When combined with the timing of MAVEN's failure and the lack of close-range data, the orbital alignment starts to feel less like an isolated curiosity and more like part of a growing list. Each item on that list may have a natural explanation, but together they create pressure on the simplest assumptions. At this stage, the question is no longer whether 3I Atlas is strange. That much is clear. The harder question is whether its strangeness fits within the range we expect from random interstellar debris, or whether it sits just outside that range, nudging scientists to look more carefully. The alignment with the ecliptic plane does not answer that question, but it ensures that the conversation cannot stop here. As scientists traced the incoming path of 3I Atlas farther back in time, an unexpected connection began to surface, one that quietly changed the weight of the discussion. Its arrival direction was not scattered across an ordinary stretch of sky. It pointed toward a region already etched into scientific memory, a place associated with one of the most unsettling signals ever recorded by radio astronomy. This detail did not change the equations, but it changed how long people paused when they looked at them. In the late 1970s, a radio telescope in Ohio detected a brief but intense signal that stood out sharply from background noise. It lasted less than 2 minutes, followed a frequency associated with hydrogen, and appeared to come from a source beyond Earth that was moving relative to the Sun. The signal never repeated. Despite decades of follow-up searches, the astronomer reviewing the data circled the printout and wrote a single word in the margin. Not as a conclusion, but as a reaction. Wow. That moment became frozen in scientific culture. The wow signal was never confirmed as artificial, but it was never explained away either. It remained suspended between categories, not fitting cleanly into known natural sources and never returning to be tested again. Over time, it turned into a reference point, a reminder that the universe can produce signals we do not yet know how to classify. When researchers compared the reconstructed arrival direction of 3I Atlas to historical sky maps, they noticed something that felt uncomfortably familiar. The object's incoming path lay within roughly 9 degrees of the region associated with the wow signal, in a sky measured in tens of thousands of square degrees. 9 degrees is a narrow overlap. When probability estimates were calculated, the chance of such an alignment occurring randomly came out to about 0.6%. That number does not shout certainty, but it whispers insistently. It is small enough that it resists being brushed aside, yet not so small that it forces a conclusion. This is exactly the kind of result that makes scientists uneasy, because it sits in the gray zone where dismissal feels premature and acceptance feels reckless. It is also the kind of result that audiences remember, because it ties a cold calculation to a long-standing mystery. Emotion enters here, not through storytelling, but through implication. A single coincidence can be ignored. 2 coincidences can be debated, but when an interstellar object shows up aligned with the solar system's main plane and also arrives from the same region as the most famous unexplained radio signal in history, the mind slows down. People begin to listen differently, not because the data demands belief, but because it demands attention. Many scientists urged caution, and for good reason. The wow signal itself has proposed natural explanations, including rare astrophysical sources and even reflections of Earth-based transmissions. None of these explanations have been confirmed, but their existence weakens any direct link. From this perspective, tying 3I Atlas to the signal risks turning coincidence into narrative, and narrative into assumption. Others responded with a narrower, more careful point. Even if the wow signal was natural, its sky position is still real. That coordinate exists regardless of interpretation. The alignment, therefore, does not depend on believing the signal was intelligent. It only depends on acknowledging that two rare phenomena point back to nearly the same place. That alone, they argue, is worth slowing down for. This is where the emotional anchor locks in for many listeners. The wow signal represents a moment when the universe spoke in a way we did not understand and then fell silent. 3I Atlas represents a physical object now moving through our solar system. Something tangible that can be measured, tracked, and studied. When those two threads cross, the unknown stops feeling distant. It feels present. The reaction is not fear, and it is not wonder in a poetic sense. It is a tightening of focus. People begin to ask whether randomness alone can comfortably explain a growing stack of low probability details. They ask not because they want a dramatic answer, but because ignoring the pattern feels intellectually dishonest. At the same time, they recognize the danger of seeing intention where none exists. No responsible analysis claims that this alignment proves communication, design, or purpose. Science does not work that way. Proof requires repeatable signals, clear mechanisms, and evidence that survives hostile testing. What this alignment provides instead is pressure, the kind that pushes against the boundaries of our confidence in chance. There is also a cost to looking away too quickly. If future observations show that 3I Atlas is entirely natural, then this alignment will fade into a footnote. But if future data reveal deeper anomalies, then dismissing it now would look like a missed opportunity. Science advances by managing this tension, not by eliminating it. At this point in the story, the alignment with the wow signal acts like a spotlight rather than an answer. It does not tell us what 3I Atlas is. It tells us that the object intersects with unresolved questions we already carry. That intersection is what makes it hard to forget. For many people following this unfolding story, this is the moment curiosity sharpens into something more durable. The question shifts quietly but firmly, from whether this is interesting to whether it is safe to assume it is random. Once that question takes hold, it does not fade easily, even in the absence of conclusions. Another feature of 3I Atlas pushed the debate into even more uncomfortable territory, because it seemed to contradict one of the most basic rules people learn about comets. When most icy objects approach the sun, they heat up, release gas, and form a tail that is pushed away by solar radiation and the solar wind. This is not a subtle effect. It is strong, predictable, and so consistent that it has become almost intuitive. Tails point away from the sun. Always. 3I Atlas did not fully follow that rule. Alongside the expected outward flow, observers detected a distinct jet or plume that appeared to point back toward the sun. For people seeing the plots and processed images, this was deeply unsettling. Not because it looked dramatic, but because it looked wrong. Geometry alone makes such a feature hard to explain, since sunlight and charged particles should push material in the opposite direction. To make sense of this, some researchers proposed natural explanations. One idea suggested that the object might be rotating in a way that caused gas to vent from a specific region, briefly creating the illusion of a sunward feature. Another possibility involved complex dust dynamics, where larger particles lag behind and appear from certain angles to form a structure pointing inward. These explanations are not unreasonable, and similar effects have been discussed for other comets under very specific conditions. The problem is that 3I Atlas did not behave like those edge cases in a clean way. The sunward jet appeared persistent enough to resist simple geometric tricks, and its strength raised further questions. To produce that level of activity through normal sublimation, the surface area exposed to sunlight would need to be unusually large or unusually efficient. That requirement strains what we expect from a natural object of this size and composition. This is where the emotional anchor tightens. People are comfortable with strange shapes and odd paths, but they are less comfortable when cause and effect start to blur. When an object seems to push material toward the very source that should be pushing it away, it triggers a sense that something fundamental is being challenged. Even listeners with no background in astronomy can feel that tension. Because the rule being broken is simple and visual, some scientists raised a more provocative possibility, carefully framed but hard to ignore. If the jet is not driven by sunlight, then another energy source must be involved. That does not automatically mean technology, but it does expand the list of explanations beyond standard comet physics. At this point, words like propulsion begin to appear, not as claims, but as questions. The idea that the sunward jet could be acting like a controlled exhaust is deeply controversial, and most researchers approach it with extreme caution. Space is full of surprises, and history is littered with natural phenomena that once looked artificial. Still, the shape, direction, and persistence of the jet forced scientists to confront an uncomfortable gap between observation and explanation. For the audience following this story, this is often the moment when skepticism and curiosity collide. It is easy to dismiss one odd feature. It is harder when that feature directly contradicts expectations that have held true across countless observations. The question becomes less about believing in an extraordinary answer and more about admitting that the ordinary answers are under strain. Importantly, no one claims that a sunward jet proves intent or intelligence. Science does not allow that leap. What it does allow is careful discomfort. The recognition that something does not fit neatly into known categories. That recognition is not a failure of science. It is often the beginning of progress. As 3I Atlas continued on its path, the sunward jet remained one of its most troubling signatures. It did not shout or flash, but it lingered quietly in the data, refusing to go away. For many observers, that quiet refusal carried more weight than any dramatic claim ever could. As attention stayed fixed on the jets, another layer of data added pressure to the discussion, this time coming from chemistry rather than motion. When scientists analyzed the light coming from the gas around 3I Atlas, they were not just looking for brightness or shape. They were breaking that light apart, searching for fingerprints that reveal what the object is made of. What they found did not sit comfortably with expectations. One element stood out more than the rest: nickel. Nickel is not unknown in space, but it rarely dominates the gas clouds of comets or small icy bodies. In the plume of 3I Atlas, the ratio of nickel compared to compounds like cyanide was far higher than anything seen in similar objects. Not slightly higher, but orders of magnitude beyond known natural cases. For many researchers, this was the moment when the conversation shifted from unusual to hard to explain. It's Bill. To understand why this matters, it helps to think about where nickel usually comes from. On Earth, nickel is closely tied to metal alloys, industrial processes, and refined materials. In space, it is typically locked inside solid rock or metal, not freely floating in gas form in large quantities. Releasing that much nickel into a plume requires conditions that are not easy to achieve through simple heating by sunlight. Several natural explanations were proposed. One idea suggested that the surface of 3I Atlas might contain nickel-rich minerals that vaporize under extreme conditions. Another pointed to violent collisions in its past, possibly exposing metal-rich layers that are now eroding. These ideas are not impossible, but they come with costs. Each requires a specific and somewhat unlikely history. Stacked on top of an already unusual object, this is where the emotional anchor deepens. When listeners hear about strange paths or odd jets, those feel abstract. Chemistry feels different. Chemistry feels concrete. It asks a direct question: how did this material get here in this form? When the answer is unclear, the discomfort becomes harder to dismiss as imagination. The nickel problem becomes even sharper when energy is considered. To sustain the observed plume using sunlight alone, 3I Atlas would need to absorb and convert an unusually large amount of solar energy. That implies either a surface far larger than expected, a structure unlike typical small bodies, or an additional power source. None of these options are comfortable, but ignoring the question is no longer easy. Some researchers cautiously raise the idea that the material composition could hint at processing rather than formation. Processing does not automatically mean intelligent design, but it does suggest transformation under controlled or extreme conditions. In everyday terms, it raises the difference between something that formed naturally and something that was altered after formation. That distinction matters, even if no conclusion is drawn. For skeptics, this is where alarms go off. History is full of cases where unusual chemistry was later explained by overlooked natural mechanisms. They warn, correctly, that jumping from nickel to machinery is a mistake. Yet even skeptics admit that the numbers are uncomfortable, because they push beyond what standard models predict, without adding layers of special circumstances. For many in the audience, this is the moment when the story stops feeling speculative and starts feeling unresolved. The data is real. The measurements are real. What is missing is a clean, simple explanation that fits without strain. When science reaches that point, it does not declare answers. It pauses and rechecks assumptions. 3I Atlas does not announce its nature through words or signals. It does so quietly, through ratios, spectra, and energy budgets. The unusually high presence of nickel is one of those quiet signals. It does not prove intent, origin, or purpose, but it presses on the edges of what we comfortably call natural. As with the jet and the orbit, this chemical anomaly refuses to stand alone. It stacks with the others, adding weight without adding clarity. For many observers, that stacking effect is the most unsettling part of all. Beyond its strange chemistry and unusual jets, 3I Atlas showed another behavior that made careful observers slow down and check their assumptions. As astronomers tracked its motion across the sky, they noticed that gravity alone did not fully explain how it was moving. The object was not following the exact path predicted by the pull of the sun and planets. Instead, it showed signs of non-gravitational acceleration, a small but measurable push that did not fit neatly into standard models. Non-gravitational acceleration is not unheard of. Comets often experience it when gas escapes from their surfaces, acting like a natural thruster. As material streams out, it produces a gentle recoil, nudging the object off its purely gravitational course. In most cases, this effect lines up with what we see: visible outgassing, predictable directions, and energy budgets that make sense under sunlight alone. With 3I Atlas, the numbers did not settle so easily. The measured acceleration was real, but the visible activity did not seem sufficient to explain it. When researchers tried to balance the force required against the amount of gas and dust being released, the equation felt strained. Either the object was expelling more material than could be clearly observed, or something else was contributing to the push. This is where the emotional tension sharpens. Because motion feels fundamental, shape can be deceptive. Light can be misleading. But motion, especially repeated and measured motion, is harder to argue with. When an object consistently drifts away from its expected path, it forces a question that is both simple and unsettling. What is pushing it? Several natural explanations were explored. One idea suggested that the object might be releasing gas in a highly focused way, creating a stronger push than expected from a small area. Another proposed that very fine particles, hard to detect directly, could be escaping and carrying momentum away. These ideas are plausible, but they require conditions that are precise and, once again, stacked on top of other unusual traits. For some scientists, the pattern was becoming uncomfortable. Each anomaly on its own could be managed. Together, they began to feel less independent. A sunward jet, an unusual chemical signature, and now unexplained acceleration all pointed toward the same problem: energy. Something was providing force in a way that standard comet physics struggled to account for without stretching assumptions. This is the point where words like engine begin to appear, always surrounded by disclaimers. No one serious claims that 3I Atlas is definitely powered by technology, but the language itself reveals the tension. When natural explanations start to resemble descriptions of controlled thrust, it signals that the gap between observation and model is growing for the audience. This is often a turning point. Up to now, the story might feel like a list of curiosities. Acceleration changes that. It suggests activity rather than passivity. The object is not just being acted upon, it appears to be acting, however subtly, on its own path. That shift, even if later explained naturally, leaves a strong impression. Skeptics remain firm, and their caution is warranted. History shows many cases where mysterious accelerations were later resolved with better data or improved models. They argue that the universe is efficient at surprising us without needing intent. Still, even skeptics acknowledge that 3I Atlas demands more explanation than usual, not less, emotionally. The anchor here is quiet but powerful. An object from outside the solar system is not just drifting through like cosmic debris. It is adjusting, nudging, refusing to behave exactly as expected. That does not mean it has purpose, but it does mean it has agency in the physical sense, driven by forces we do not yet fully understand. As the data accumulated, the non-gravitational acceleration of 3I Atlas became harder to treat as a minor footnote. It joined the growing stack of unresolved details, each one small, each one defensible, and together, increasingly difficult to ignore. As researchers reconstructed the full timeline of 3I Atlas moving through the inner solar system, One detail stood out for how quietly precise it was. The object reached its closest point to the Sun, the moment known as perihelion, without being observable from Earth. This was not because telescopes failed or data was ignored. It was because geometry placed the object in a position where the glare of the Sun made direct observation impossible from our planet. Perihelion is usually the most valuable moment for studying a fast-moving object. That is when heating is strongest, when jets are most active, and when structure and composition are easiest to probe. For comets and interstellar visitors, this is often when the clearest answers emerge. Yet for 3I Atlas, that window closed before it ever opened. By the time Earth-based instruments could look again, the moment had already passed. On its own, this might seem like bad luck. Space is full of blind spots, and not every object cooperates with our viewing angles. But when scientists calculated how narrow this timing window was, the discomfort grew. The probability that an object with this trajectory would pass through perihelion entirely hidden from Earth-based observation was estimated at less than 0.005%. That is not zero, but it is small enough to make people stop talking and start listening. This is one of those moments where emotion enters through silence rather than spectacle. Nothing dramatic happened on screen. No explosion. No flash. No sudden maneuver. Instead, the most important observational moment slipped by unseen. For many listeners, that absence feels heavier than any image ever could. It feels like arriving late to a conversation and realizing the most important sentence has already been spoken. Some scientists emphasize that this does not imply intention. The solar system is a three-dimensional place, and alignments can work against us. They caution that probability estimates depend on assumptions and models that can change. From this view, the missed perihelion is unfortunate, but not suspicious. A reminder that our perspective from Earth is limited. Others respond with a narrower question, even if intention is not assumed. Why does 3I Atlas repeatedly pass through critical points at moments when observation is hardest? First, the brief window near Mars, tied to MAVEN's silence. Then the perihelion passage hidden by the Sun. Each event can be explained alone. Together, they begin to feel coordinated, even if no coordinator is named. This is where the emotional anchor tightens again. Science thrives on data, and here the data is defined by what we do not have. The object was most active when we could not see it. The measurements that might have settled debates were blocked by geometry. That absence does not prove anything, but it leaves the mind restless, circling the same question from different angles. For the audience, this moment often triggers a quiet reaction rather than excitement. It is the feeling of something slipping through your fingers, not because you were careless, but because the timing was just slightly off. When that happens once, it is frustrating. When it happens multiple times in the same story, it starts to feel personal, even though it is not. Importantly, no claim is made that 3I Atlas chose to hide. Physics does not assign motives, but physics does allow us to notice patterns. And here, the pattern is one of critical moments aligning with limited access. That pattern does not answer questions, but it keeps them alive longer than expected. As 3I Atlas moved away from the Sun, the chance to observe its most intense activity was gone for good. What remained were secondary effects, fading jets, and indirect clues. For some researchers, this was simply the cost of doing astronomy from a single planet. For others, it was another reminder that this object seemed to pass through the solar system on its own terms. The missed perihelion became more than a technical detail. It became part of the story's emotional weight, not because it suggested a hidden hand, but because it reinforced a growing theme whenever the clearest answers might appear. Something seems to stand in the way. As 3I Atlas continued outward, attention shifted to what lay ahead rather than what had already been missed. Its trajectory pointed toward a close passage by Jupiter, scheduled for March of the year 2026. The distance of that encounter was calculated at roughly 53.6 million kilometers, close enough to matter in a gravitational sense, even if it sounds vast by everyday standards. In planetary dynamics, this distance places the object near the outer edge of Jupiter's Hill sphere, the region where the planet's gravity can dominate over the Sun's for smaller bodies. The Hill sphere is not an abstract concept. It defines where objects can be captured, redirected, or stabilized into long-term orbits. For Jupiter, the largest planet in the solar system, this region is enormous. It acts like a wide gravitational net, shaping the motion of moons, dust, and passing objects. When something passes through or near this zone, it can be slowed, bent, or temporarily trapped in ways that do not happen elsewhere. For most natural objects, a pass like this is just another step in a long journey. Gravity does what gravity does, and the object moves on. But in the case of 3I Atlas, the context changes how this future encounter is perceived. After everything already discussed, the Jupiter passage feels less like a footnote and more like a checkpoint. It is a moment where the object enters a region known for stability, leverage, and long-term presence. This is where some researchers began to speak carefully about strategic geometry. Jupiter's system contains multiple Lagrange points, locations where gravitational forces balance in a way that allows objects to remain in place with minimal energy. These points are prized in space exploration because they offer stable positions for observation. If a probe or satellite were ever to be deployed deep within the solar system, Jupiter's Lagrange regions would be among the most efficient places to put it. Here, the emotional anchor shifts from mystery to anticipation. Nothing has happened yet. There is no new anomaly to point to, no fresh data to debate. Instead, there is a sense of waiting, the feeling that the story is not finished. For many listeners, this future moment carries more weight than the past ones, because it represents a clear opportunity for change. Some speculative theories describe 3I Atlas as a possible carrier, a larger object capable of releasing smaller probes. This idea is dramatic and controversial, and most scientists treat it with extreme caution. There is no direct evidence of deployment mechanisms, and no observation has shown smaller objects separating from it. Still, the theory persists because the geometry invites it. A close pass by Jupiter offers leverage that would be difficult to ignore if an object had any capability to act on its surroundings. Skeptics push back hard here, and rightly so. They point out that countless comets and asteroids pass Jupiter without incident. Gravity assists and close approaches are common in celestial mechanics. From this view, the upcoming passage is only interesting because we have chosen to make it interesting. There is no rule that says a strange object must do something dramatic simply because the stage is set. Yet, even skeptics acknowledge that the Jupiter encounter matters more for 3I Atlas than it would for a typical visitor. That is because Jupiter is not just another planet. It is the gatekeeper of the outer solar system. a gravitational anchor that has shaped the paths of countless objects over billions of years. When something unusual passes close to it, the interaction deserves attention. Emotionally, this moment taps into a familiar human response, the feeling of standing before a door that might open, or might remain closed forever. The object has already passed the moments we could not see clearly. What lies ahead is one of the few remaining opportunities where change, capture, or redirection could occur in a measurable way. Importantly, no claim is made that 3I Atlas will do anything at Jupiter. It may pass through quietly, unchanged, leaving nothing behind. But the alignment of its path with such a powerful gravitational region ensures that eyes will be watching. This time, the moment will not be hidden by the sun or blocked by geometry. As the date approaches, the Jupiter passage acts like a silent countdown in the background of the entire discussion. It represents a future test, not of belief, but of expectation. If nothing happens, some questions may finally settle. If something unexpected occurs, the conversation will change again. For now, Jupiter stands ahead like a marker on a long road. 3I Atlas is still moving, still measurable, still unresolved. And that sense of unfinished motion is what keeps the tension alive. At this point, the story of 3I Atlas does not resolve into a clean conclusion. Instead, it settles into a boundary, the line where data ends and interpretation begins. Every unusual feature we have discussed can, in isolation, be placed into an existing scientific framework. None of them openly violate known physical laws. Yet, when they are viewed together, they resist being smoothed out into something ordinary. That resistance is subtle, but it is persistent. The silence of the MAVEN spacecraft sits at the front of that discomfort, a long-running mission, stable for years, went quiet immediately after observing one of the most unusual interstellar objects ever recorded near Mars. That silence does not accuse anything, but it does remove a critical voice at the exact moment when clarity was needed most. In science, missing data is often more troubling than strange data because it leaves space for uncertainty to grow. Then there is the path 3I Atlas followed into the solar system. Its close alignment with the ecliptic plane does not break any rules, but it challenges expectations about randomness. Objects arriving from interstellar space have no known reason to favor the same flat geometry as the planets. When one of the few we have ever observed does so, it invites a longer look, not because it proves design, but because it strains probability. Layered onto that is the alignment with the direction of the WOW signal, a historical anomaly that has never been fully explained. The overlap does not confirm a connection, and no responsible scientist claims that it does. Yet it adds emotional weight to the discussion, because it links a present-day object to a long-standing unanswered question. It reminds us that unresolved mysteries do not vanish with time, they wait. The physical behavior of 3I Atlas deepens the tension further. A jet directed toward the sun challenges a basic visual rule that is held across generations of comet observations. Unusual chemistry, especially the high presence of nickel relative to expected compounds, pushes against known formation and energy models. Non-gravitational acceleration suggests a source of force that does not neatly match visible outgassing. Each of these features can be argued down individually. Together, they demand more explanation than usual. It is important to be precise here. None of this confirms that 3i Atlas is artificial. None of it demonstrates intent, intelligence, or engineering. Science does not move forward by stacking suspicion and calling it proof. It moves forward by identifying where current models struggle and then asking why. Right now, the models are working harder than they usually have to. This is where the real scientific tension lies. When explanations begin to rely on multiple rare conditions happening at once, scientists pause. They do not abandon the natural explanation, but they question whether it is complete. That questioning is not a failure of skepticism. It is an expression of it. Healthy skepticism does not dismiss anomalies automatically. It tests whether dismissal is justified. There is also a broader issue at stake, one that goes beyond 3i Atlas itself. For most of modern astronomy, interstellar objects have been treated as debris, fragments ejected from distant systems with no story beyond gravity and time. 3i Atlas challenges that habit, not by offering a new narrative, but by making the old one feel thin. It asks whether our category of natural interstellar object is too coarse to capture everything the universe can produce. Some researchers argue that patience is the only responsible response. More detections will come. Better surveys will find more interstellar visitors. If future objects show similar alignments, chemical signatures, or accelerations, then what feels exceptional today may become normal tomorrow. That outcome would strengthen science, not weaken it. Others warn of a different risk. If every anomaly is smoothed over too quickly, science may miss the early signs of a new class of phenomena. History offers many examples where the first hints of something new were dismissed because they were inconvenient. In those cases, the mistake was not skepticism, but haste. Emotionally, this is where the story carries its quiet weight. There is no dramatic reveal, no final image that explains everything. Instead, there is the uneasy feeling of standing in front of a pattern that is incomplete. The discomfort does not come from fear or wonder, but from unfinished understanding. That feeling is deeply human and deeply scientific. 3i Atlas may ultimately be explained in entirely natural terms. If that happens, the questions raised here will not have been wasted. They will have sharpened our methods and clarified our assumptions. Science advances just as much by closing questions as it does by opening them. But if future observations deepen the inconsistencies rather than resolve them, then this moment will matter. It will be remembered as the point where the data first pushed hard enough to slow us down, not to convince us of anything extraordinary, but to remind us that the universe does not always fit neatly into the boxes we prepare for it. In the end, the most honest thing we can say about 3i Atlas is also the most unsettling. The object has passed through our solar system, but it has not passed out of our questions. Those questions remain in motion, circling our understanding, waiting for either resolution or revision.